Today we've got two wonderful speakers who'll be sharing with us about the dashboards that they've created and sharing the knowledge and experience of creating dashboards using various packages in R. Unfortunately, our third speaker had to drop out last minute, but that just means we've got more time for Q&A and hopefully a long tea break. So the format of this session is that we've got pre-recorded presentations. We'll be playing them both back to back, but then we have both our speakers available for a live Q&A. So feel free to put any questions in the chat box and we can have a panel style Q&A after both the presentations. Our first speaker today is Edward Parker, who is an infectious disease researcher at the London School of Hygiene and Tropical Medicine. His work often involves making sense of complex data sets, something that static graphs or charts often struggle to achieve. And therefore, over time, he's become interested in making clear and interactive visuals using really complex data. Our second speaker is Aidan Boland, who is a senior data scientist at Edge, which is an e-commerce firm. He has been developing RShiny apps for the past 5 years, both as a part of his job and during his personal time. He is a supporter of open source software and therefore loves to publish his code whenever possible. So I guess we can start the presentations now.
The key messages I want to convey are simply ones of encouragement. If you're an R coder, give Shiny a try, however experienced you are. I found it to be a really powerful way to build quite elegant data visualizations. And I certainly hope that Shiny and equivalent platforms become an increasing part of how we communicate data in the future. And second, don't be afraid to stand on the shoulders of giants. The Shiny gallery is absolutely full of amazing apps with linked code. And if I'm completely honest with you, the case tracker I developed is in many ways a hybrid of borrowed parts from existing apps that I've bolted together in a new way. Add a brief disclaimer that because the app is made in Shiny, the talk becomes a little bit centered on R coding when we get into the nuts and bolts, although I do hope that some of the general ideas will be of interest to a broader audience that perhaps isn't so familiar with R. Before we dive into the app, a quick introduction. So I'm an infectious disease researcher in the Vaccine Centre at the London School of Hygiene and Tropical Medicine. When I'm not making Shiny apps, my work looks at trying to understand why all vaccines are less effective in low-income tropical countries, with a particular emphasis on the role of the microbiome. And in practice, this involves a mixture of lab work and bioinformatics. But I think it's worth emphasizing from the outset that I'm a reluctant coder. All of the figures in my PhD were made in Microsoft Excel, and it's only as a postdoc that I've started to gradually warm to coding, and really only in the last year or so that I've become a true convert. But I've always been a fan of nice graphs, and the late Hans Rosling is a personal hero, and as far as I'm concerned, his website, Gapminder, is still the absolute gold standard when it comes to interactive data visualization. So this website may or may not be familiar to you, but if not, I'd strongly encourage you to check it out. Right, so without further ado, let's take a look at the app. And since this is a session on interactive data, I'm going to attempt to switch seamlessly away from the slides and onto the app itself. So here's the dashboard. The website address is in the slides, and you can also find it on the RShiny gallery. And as you can see, the main page features a world map, which you can scroll around and zoom in or out of using this toggle on the left-hand side. The circles here display the extent of the COVID pandemic within the last 24 hours. So you can hover over any country to see the number of newly diagnosed cases and COVID-related deaths. For example, if we hover over Spain, we can see that on the 2nd of September, which is when I'm recording this, there were 8,500 odd cases within the last 24 hours and 42 COVID-related deaths. Well, in the UK, we had just over 1,500 cases and 10 COVID-related deaths. And that corresponds to 2.2 cases per 100,000 individuals in the population. And as I'll discuss later, these numbers are extracted daily from the database curated by Johns Hopkins University, who've really been at the forefront of mapping the COVID pandemic from the outset. So there are a few other key features on this page. Using the checkboxes here on the bottom right-hand side, you can switch between new cases and cumulative cases. And you also have the option to overlay past outbreaks, including SARS, H1, and Ebola. So for example, if I tick the Ebola box here, we can zoom in and see the extent of the 2014 Ebola outbreak in West Africa. Right, so now I'll zoom back out again so we can see the world map. So another key feature that remains relatively unique to this dashboard is the ability to wind back the clock using this toggle on the left-hand side. And with this, you can visualize the state of the pandemic on any given date. So I think this feature offers a really valuable insight into some of the key windows in which the pandemic accelerated. So for example, we can see that the month of March was incredibly important to the spread of COVID. At the beginning of the month, you had about 70 countries infected with 88,000 cases in total. But then if we wind forward to the end of the month, you can see that we've sort of getting up towards 1 million cases, so 870,000 cases in 180 affected regions. And you've had this huge exponential increase in the case counts globally. So this is a month where the virus went from infecting a handful of countries to really infecting every corner of the globe. So this interactive map is really the foundation of the dashboard. But while maps are certainly good at presenting certain kinds of data, they do struggle to capture trends in time. And so with this in mind, about a month after launching the app, I added the region plots dashboard. So here you can plot various outcomes using the selectors on the left-hand side, including normalized COVID-related deaths and cases, or the total numbers. So here, for example, I'll switch to total case counts, and you can plot these either cumulatively, new daily cases, or cumulatively on a log scale. So here I'll switch to new case counts. Using these drop-downs on the left-hand side, you can switch between global counts, continent-level counts, country or US states. So, for example, here I'll switch to continents. And here we can sort of see the daily case counts by continent. And then finally, you can choose when to sort of anchor the x-axis of this plot. So at the moment I've shown date, but because the virus arrived in different places at different times, it's quite hard to compare the trajectory. So if we switch here, we can put the start date as the day of the 100th confirmed case, for example. And then it's sort of a fairer comparison of what happened after the virus had arrived. So there are a few other tabs, but these are really the key parts of the app. Do go on and check it out for yourself. I've also published all the code required to generate the app on GitHub. So do go on there and please try to be forgiving and don't judge me too harshly for the poorly annotated code. So the GitHub account is eParker12, which I've shown here. So now that's the app, and so if we switch back to PowerPoint, I'll now talk briefly through some of the key nuts and bolts to give you a sense of how the app operates. So the first key building block is a data frame containing a few basic parameters for each country. This includes the latitude and longitude, which act as the center points of the circles in the map. And it also includes population sizes according to recent data from the UN, which are used to calculate the normalized case counts per 100,000 individuals. The second building block is a data frame of COVID-related cases and deaths by date. So here I've shown the top of the data frame with the data for the 22nd, 23rd, and 24th of January. But of course, these data aren't static. So a key challenge for the app is how to keep it up to date. And this is a process that has certainly been refined over time. So from the outset of the pandemic, institutes including the WHO and Johns Hopkins University have done a really incredible job of making the latest data on case counts publicly available. When I first developed the app, I used to start every day by downloading the latest PDF from the WHO, manually extracting the latest numbers and bolting on that day's data to the bottom of the growing data frame. But obviously, this is a job that became harder and harder as the virus spread. So at the end of February, I worked with Quentin Leclerc, a PhD student at the London School, to develop a script that automatically downloads the latest daily data from the GitHub page curated by Johns Hopkins University. And this effectively automated the process of bolting on each new day's worth of data to the current data frame. And ever since we finished the script, the app has been updating itself daily, and I just check in from time to time to make sure there are no glitches. Now, it's one thing to have the data, but of course the next thing is to map it. And this is where the leaflet package comes in. And in terms of the interactive elements of the dashboard, such as the scrolling and zooming features, it's really the leaflet package that's doing all the heavy lifting. I've shown the chunk of code for the basic map at the top of the slide here. And as you can see, it's only about 10 lines long. And this code is doing a few key things, including adding the checkbox on the bottom right-hand side of the page, choosing the style of the map from the various options available in the leaflet package, and adding the legend colored by cumulative COVID-related deaths per 100,000 individuals. So that's the basic map that sort of starts the app. But finally, we get to the real internal cogs of the dashboard. Now, I don't want to get too caught up in the details of Shiny apps. There are some fantastic tutorials for this online. But the basic principle is that you have two interacting chunks of code. One for the user interface, or UI, which is basically the bit you can see, and one for the server, which is the bit you can't see running in the background. And in essence, the server is reacting to changes you make in the user interface and updating the maps, plots, and figures accordingly. So I thought I'd illustrate this cycle of interaction for one of the key elements of the case tracker. As we saw a few moments ago, the main mapping page of the user interface has a slider which you can use to select the date. So this is coded by the slider input function in the Shiny package, which I've shown here on the right. So it's this chunk of code that gives you the ability to select the date on the user interface. Now, when you change the date, two key things are happening in the server. First, a subset of the input data is created corresponding to the selected date. So that's pretty simple, one line of code to create that subset. Next, we need to add the circles for that date to the leaflet base map. And I've shown some of the key code for this here. And this is doing a couple of things. It's clearing the existing circles from the map. It's then reading in the new data subset that we've just created. And then it's adding circles. And here you simply need to specify the location of the circles based on the latitude and longitude, the size of the circles based on the case counts, and the label that appears when you hover over the circle. And all of this information is derived from the input data that I just described. And then if we switch back from the server to the user interface, these updates are then being rendered on the map. And the app then continues to work in this cycle of interactions, which are passed from the user interface to the server and then back again. Now, I've slightly simplified things in this example. And if you're keen for more details, you can look at the complete code on GitHub, and I've included the address for this on the bottom of this slide. But I just wanted to provide a kind of brief summary of the sorts of mechanics underlying the dashboard. And I hope it's been somewhat intelligible. So I thought I'd finish with a couple of final reflections based on my experience building this dashboard. and a few other Shiny apps that I've worked on since. So firstly, personally, I've found it easiest to start from a blank slate and build the dashboard piece by piece. Shiny has its own unique mechanics, and it's generally been simpler to build the app from the ground up rather than to try to adapt previous bits of code. Secondly, I'd really recommend just getting stuck in, as I mentioned earlier. Start building your dashboard, then use the online tutorials in Shiny Gallery to help when you need them. I've had learn to use Shiny on my to-do list for a long time, but I learned more in a week when I started building my own app than I had in several years before that. Finally, get creative. It's not very often that we think of science or data visualization as a creative pursuit, but I really think it should be. And I'm increasingly inspired by the ways that these sorts of tools are being used to present data in informative ways. But I do want to finish with one final reflection. I think the current pandemic has been a watershed moment for data journalism, and every news outlet has its own online dashboard tracking various facets of the outbreak. These visualizations have undoubtedly helped communicate the scale of the pandemic incredibly effectively. But the numbers also distance us emotionally from the human stories behind every case. And this constraint certainly applies to the dashboard I've just described. And it's something I try to remind myself of each time I look at the rising numbers of this pandemic. And with that thought, I'd like to thank you all for your time. It's a real privilege to be presenting today. And I'd like to thank the organisers for inviting me to be part of this. And I look forward to joining you all shortly for the Q&A.
I'm going to have three parts to the presentation. An introduction where I will just give you some background information on myself. I will tell you about my journey with Shiny so far. I'll then, in the middle part, give some examples of Shiny apps, so 2 Shiny apps that I've developed. And I'll finish off with just some tips and some thoughts on deployment, because it's nice to create the Shiny apps, but it's much more important to actually be able to deploy them and for people to be able to actually use them. So I think it's quite an important aspect that can be overlooked sometimes. So me, I'm Aidan Boland. I was educated in UCD Dublin. So I did my bachelor's, master's, and then a PhD, all in UCD. I did my PhD under the guidance of Professor Niall Friel. And I finished that, then I did another year as a postdoc in the Insight Centre for Data Analytics. That was with Professor Andrew Parnell. And at that stage, in mid-2016, I joined a company called Clavis Insight. So they were an e-commerce analytics startup, and they were then acquired by Essential, an English company, at the end of 2017. So essentially, I've been working with the same company since I joined Clavis Insight, but we've gone through some changes within that company in terms of being acquired. And then after a year of still being Clavis Insight, Essential decided to join 4 of their companies together and create a new brand called Edge by Essential. And that's the company that I'm currently working at. They're also e-commerce analytics. What we do is we track the online retail space. So if you're selling products on an online website such as Amazon or Tesco, we'll track your products. We'll let you know how they're performing in terms of ratings or reviews. We'll look at your product titles. So an important one for brands is to make sure they have their brand name in a product title. So if you don't have that, you're not going to show up in search. So we will surface all that information and let you track your online portfolio, which in theory should allow you to improve your online presence. In terms of Shiny, I first created a Shiny app back in 2015. It was the beginning of the postdoc, and that was to help with a teaching app. So I was helping out with an introduction to statistics module, and we wanted to help give students some information on regression and correlation, and let them understand and play around with some data to get a better understanding of regression and correlation. And so I'd come across Shiny and decided I would put together a Shiny app and see if I could get something that was interesting and useful to the students. So this is the app here. It's you see there's 3 different tabs. There's a game, there's a tab on linear regression, and a tab on correlation. So in terms of the regression and correlation, it lets the students look at different data sets. There's drop-down boxes in Shiny that give you different data, some ones that would be familiar to statisticians, such as the IRIS data set or Old Faithful, Anscombe's data. It gives them a data description of that data, which will change as you change the data. In terms of Anscombe's, you can select any of the 4 data sets for Anscombe. So Anscombe's data is a set of 4 data sets that all have the same regression line. So no matter which data set you pick, the regression line stays the same. You'll see the data is much different, but it gives students an opportunity to explore this and explore regression. It also gives them a table of the actual data and the calculation. So if you're used to LaTeX, you can add LaTeX into your Shiny app or dashboard. And so this gives the students the actual calculations it takes to create this line. Similarly, for the correlation, it just picks some random data. The students can use the sliders to choose the number of observations they want and choose what the correlation. So it lets them show if they have a correlation close to 1, there's a positively correlated data set created. If you go close to 0, it should be quite a random scatter. Again, they can see the table of the data and also the calculations for the correlation coefficient. So it gives the students an opportunity to play around with data, look at different types of data sets, and hopefully get them better understand both regression and correlation. There's also a linear regression game, which I created, which allows you to try and choose the correct regression point or line by clicking 2 points in the plot. You plot the line. The red one is the one I picked. The blue dotted line is the actual fitted least squares regression line. And there's a scoring system used in this, which I actually don't remember exactly how I create the score, but essentially gives a value for how close you are to the true line. And there's a finite number of data sets. You can put in your initials. So in theory, the students will go through it, and there will be a leaderboard of which students are getting closest to the actual fitted lines. So this was part of that teaching app. That was my very first Shiny app. It did take quite a while to put together fully, but it was quite good, and it kind of showed me how useful Shiny can be, because it lets the students are coming in as first years. They're not used to using programming languages like R, so it's much harder for them to actually explore data. This gives them a very easy way to actually get stuck in and play around with the data. The second app I created was during my postdoc. So this was needed because we'd created an algorithm to classify products. So as products, I say, are online products. So it was, we took a bunch of different online products and we wanted to categorize them. So we found the optimum classification algorithm, which would allow us to automatically classify these products. But we needed a way of allowing a non-technical user to run the classification. So we'd done all the background work around finding the best algorithm, but we needed to get that in front of people who could actually use it. And those people weren't familiar with, say, R or any programming language, so they weren't going to be able to actually run the code as just raw functions. So we used Shiny to allow them to run the code, but just give them a UI in the front end. So I don't have a live version of this app because it is a proprietary app, but here's a screenshot. And essentially a user can drop in 2 CSVs, a training file, which is a set of products which already have classifications, and then a harvester candidate file, which is a set of products which they want to be classified. And essentially they can click a couple of buttons and the algorithm in the background will run and automatically classify the products, and they can then download that CSV file. So it allowed non-technical users to get access to the algorithm which we had researched and developed. So in my current role, I actually have about 6, I think, apps that are in use at the moment inside in Edge by Essential, and they're for various different uses. So they're not all just dashboards for visualizing data. Some of them are more like the UI I just showed in terms of allowing non-technical users to run code. So as I see, the first use is run an ML algorithm or a classification algorithm. So that's one of the uses. Others are ETL, which is extract, transform, load. So basically it lets them access a database, pull out some data, it'll transform the data into a different shape and then load it back into a different area or download it. So it will process the data for non-technical users using functions which I've written. There's also one very simple one, which is just database access. So some people will obviously not be familiar with SQL, but they'll need to get some data out of the database. And we were able to use Shiny to create a very simple interface that lets them select a date range, select certain other options, and then it will download the data from the database. It will transform it into a suitable structure and let them download that data. So it's essentially just a front end onto a database, which allows a user who is not familiar with SQL to actually get the data and download it. So it's quite a simple use, but Shiny was quite good for that. What I'm going to show today are actually two personal projects, and these are more around exploring and visualizing data. So they'll hopefully be a bit more interesting. And these came about just from data sets I found, which I thought were interesting. And as we come on to the second example, just something I wanted to try make a bit easier for myself in my life. So these are the two dashboards I'm going to go into in more detail. The first one is on football data. You can see all the code at that GitHub link you see on the slide. And I was looking to try to get more of the European leagues in as well, but at the moment it's just Premier League data, and it has data for the last 20 years. And so you can dig into various statistics around teams for the Premier League for the last 20 years. The second one we come on to is around Dublin Bus. So it's the local public transport in Dublin. And I use a public API to get the real-time bus information and to collate it from multiple stops. So I'll go into more detail on the Dublin Bus when we get to it, but first we'll look at this football data. So here is the Shiny app itself. You have two different stats, so it just creates a simple scatter plot. You can select a few different statistics. There's goals scored, goals conceded, shots on target. There's also date range, so you can pick, I think it goes back as far as 2000. So if you wanted, you could go to 2000 and you have data for all the teams, goals scored, goals conceded since 2000. So it allows you to explore all that Premier League data. It will also, when you're mid-season, if you load up the app, it will get the most recent data and add it in. So it's always staying up to date with the latest scores. What I want to show as part of this app is actually, it's not quite a Shiny feature, but a feature of this plot where you can actually hover over the points and see what the values are for the teams. You can also click and drag on an area and just see the teams in that area. So it lets you explore the data a bit more. And this isn't a feature of Shiny, it's a feature of another R library called Plotly. And I found this quite useful because it can be built into Shiny apps, but it can also be built into R Markdown presentations or just HTML on its own. So Plotly is a graphing library. There are interfaces for R, Python, JavaScript. You can integrate it with ggplot2, which I know is quite popular with R users. It can also be integrated into Shiny. So the plots can be saved as just HTML files if you want, or displayed in our Markdown documents, or included in Shiny presentations, or Shiny apps, sorry. I'll show this a really simple example here. So this is ggplot. We've used the MPG dataset, which comes built in with ggplot. What we have here on the x-axis is the size of the car engine. On the y-axis is the miles per gallon on highway usage. And then they're colored by the different type of cars. So I've kept this quite simple. I haven't added any extra labels just to keep the code as simple as possible. We have our ggplot, we have our data, we tell it what we want on the x-axis, the y-axis, what we want colored. But when this is showed here, it's just a static plot. You can't see anything with it. Plotly has a very simple interface with ggplot that we simply use the ggplotly function. And now the plot has become interactive. So we can hover over the points, which gives you the values. We can do the click and drag like we did before to look at just a certain part of the graph. If we double click it, reset. We can also look at just a single type of car, or we can hide or show different types. So it allows the user themselves to go and to play with the data. And this is simply just one function. So if you already have your ggplot, use that one function, and all of a sudden it becomes a bit more interactive for the user. So it's quite a good way of letting users play with the data. One final thing with this, I just want to show as part of an R Markdown document. You'll see here in my slide, I've a slight shade of gray at the bottom and the white border around the plot. There's a very simple add-on, which is just this theme and plot background, which will get rid of that white box. So if you're putting together a presentation in R Markdown and you have a dark background, if you add in a ggplot, it'll have that white box around it. This extra line here will just make that transparent, and so your plot will look much nicer against your background. So that's just one trick that I came across a while ago that I think could be useful. In terms of including Plotly with Shiny, again, there's the Plotly library has Plotly output and has render Plotly. So if you copy and paste this code into a single R file, you'll spin up a Shiny app that has that plot that we just showed there. And again, it's quite straightforward to add that into a Shiny app, or if you already have a Shiny app with the ggplot, you can simply change your render and output and add in that ggplotly function. And then all of a sudden you have your plot, which is interactive and allows users to drag and copy and look at different parts of the plot, or hide and show different categories. As I said, you can also just save it as a simple HTML. So there's a save widget function. And what this will do is take that exact plot we just saw, save it as just a HTML file, which you could then email to someone. And they don't need OR then to open that up. They can just open that in Chrome, Firefox. As long as they have a web browser, that plot will open and it will be as interactive as we saw before. So it's a good way of sharing a visualization and allowing the user to actually look at the data in more detail and play around with it. The second app I'm going to show, I mentioned briefly earlier, is around the Dublin Bus, so the local public transport here. I actually included this as my entry for our Studio's Shiny contest last year, so helped me put a bit of a deadline on myself for just putting it together. What it does is it obtains data from a public API, so it gives you the time until the next bus at bus stops. That's freely available through that public API. The reason I decided to put it together, so obviously there is an official Dublin Bus app which gives you that information, but you can only look at a single bus stop at once. So if you want to look at multiple bus stops, so say where I was in my office, there's 3 different bus stops I could get a bus home from and 3 different bus routes, but none of them stop at the same stop. So to check the data at the different stops within the app, you have to go back out of the bus stop and go back into the other one. And it's not much messing around, but you're still 3 or 4 clicks to get in and out of the different bus stops to check the data. So I thought I'd go and see, could I put together an app which would actually display it all together. So this is the official Dublin Bus app. As you see, you can look at a single bus stop. It will let you filter the different bus routes, but that's as far as it goes. And so what I put together, and of course it stopped working earlier today before I started using this, so I think the API is down, but this would show the bus stops for multiple bus stops. I can actually show it more for there's also the train, which I added in. Again, you can click if you're going northbound, you can click which bus stop or which train stations you're going, and it'll give you when the next routes are coming. What is quite useful is this, so obviously when you load up and open a Shiny app like that, there's a default, train stop, which in this case is Tara Street. So that's going to always load for a user. But obviously if you're loading this app, you're only going to be interested in a certain train station. And so what I included in this is you can create your own custom URL, and it adds extra URL parameters. So I'll show a bit more here. The URL header, so the standard link for the app is here. That will load up with the default bus stops and bus routes. What you can do is you can add in stops and routes arguments in the URL, and then when the app loads up, it will actually show whatever bus stops you put in. So if I have stops equals 334 and 336, so say they're my bus stops, I can bookmark this link in my web browser. When I load up the app, it's only going to show those bus stops, and it's only going to show the routes for the number 14 and number 140 bus. So this is quite useful. This can be built into any Shiny app. So a user can add, once anything after the question mark, you can add arguments to stops and equals. And within Shiny, then you can use this parse query string argument to get at that data. And so this allows you to modify the Shiny state for a user that starts up the app. And again, it's kind of useful for someone who's coming back to the app and they don't want the default parameters set in the app or default settings. So it's quite a useful way to allow you to make your app a bit more useful for users who are returning to it and want to return to it in a certain state. Okay, so the final part I'm going to speak about is deployment. And as I mentioned at the very beginning, I think this is quite an important topic because it's well and good to create your nice Shiny app, but you actually need to get it in front of people. So to get it deployed is actually it's not that tricky. There are easier ways, there are harder ways, some more useful than others. The 2 that I'm going to focus on, the first one is shinyapps.io, which is an RStudio website that allows you to share and put up Shiny apps. It's by far the easier way, but I'll also look at Amazon Web Services, which is what I use, which has a bit more of a learning curve, but has much more flexibility around your apps, which can be useful depending on the type of user you are. So shinyapps.io, these are the 3 basic plans, or the simpler plans. There's a free, so anyone can sign up for that, and I'd recommend that. You can store 5 applications. You get 12 active hours a month, which means if people are using your apps, you have 12 hours of app usage that month. So if you're just sharing an app and you don't expect it to have high usage, that could be quite useful. The next step up is $100 a year, which is roughly £75. That bumps you up to 25 applications and 100 active hours. And it goes further on up, and there are pro plans, which are into thousands if you're in more of an enterprise setting. So the pros of this is it's really simple to deploy the app. So if you use RStudio, within a couple of clicks, you have your app deployed. There's pretty much no maintenance when you deploy the app from RStudio. It checks what version of OR you're using, checks the version of libraries you're using, and it gives all that information. So when it's deployed on Shiny apps, it'll have the exact same as how you built it in your RStudio. You also get visibility on app usage. So there's a nice dashboard which gives you visibility on when people visited your app, how much use it's getting, and you can also start and stop apps very easily there. The cons, so there's non-customizable URLs. So if you're using your free starter or basic, you have to use the Shiny Apps.io URL, which may not be a big problem, but it's sometimes nicer to have customizable URLs. Also, obviously, there's the app limits and usage limits. So depending on how many apps you want to or how much use they're getting, you may run into the limits of that quite easily. Just to show you, here is the box in RStudio that you use to publish your app. So if you're building your Shiny app with your server.or file, you click publish, it lets you select what files you want to include. You give the name of the app, and once you click publish, then it takes a couple of minutes, but it'll upload all those files to the Shiny app server, and your app is deployed straight away. You can then go in and look at the dashboard in Shiny Apps.io. It shows you when the app was used. It lets you to start and stop it. It gives it the URL. So it's quite easy, quite intuitive. It's by far the easiest way to get started with deploying Shiny apps. As I said, there is a bit more flexibility if you go to something more like Amazon Web Services. So Amazon Web Services, what I currently use at the moment, I'm paying around 114 euros or 102 pounds a year. So it is similar enough to the second plan, the Shiny apps. The pros here is the flexibility. So there's a lot more you can do with the Amazon Web Services. Essentially, you have a server that's live that people can access. So you can use custom URLs. So built into the price, I have my own custom domain. So abolan.ie, I can deploy all my apps there. So if you go to pl.abolan.ie, you get the Premier League app. So it's much nicer URLs for people to get access to. One thing that's also nice is you can use the server for other usage. So I have my own website, which is use the server stores and hosts that. You can use the server for storage if you want. You could use it to actually deploy APIs that people can access data. If you wanted to share some data, you can have an API which people can access, and it'll be at that address of the server. The cons is that it is harder to deploy apps, so you have to use a file transfer service to move the files across yourself, which is a bit more tedious. There's also the server maintenance, which has a bit of a learning curve to it. So you have to manage the server in AWS. You have to manage the libraries yourself. So you have to install OR on the server, and you have to update that yourself and update any libraries you need. So this can be a little bit trickier because it does take a little bit more time to actually log in and do those updates. The other thing that is quite a con is that it is harder to get visibility on the app usage. So you can get some visibility, but it's not as simple as the Shiny Apps solution, which gives you a nice dashboard. But in all, it is, I find it more flexible and find it, for myself anyway, my use case a bit better. So that, hopefully you've taken some good points out of it and some good tips. There's some links there if you want to get in contact with me. All the code for the apps, the Dublin Bus and the Premier League app, are on my GitHub page. And if you want to look at the code used to put together this presentation, that's also on my GitHub. So feel free to have a look at that. Thank you.
Brilliant. Thank you so much to both our speakers for such an interesting presentation. And I personally found it really interesting to see the wide range where you've got an app that's been developed to teach statistics to students, and then you've got something that's so relevant today where you've got the COVID-19 and you've got so much data and so many different dashboards being created and different interpretations of data. So yes, thank you so much to both our speakers. We've got a lot of questions, some of which have already been answered in the chat, but I'm gonna try and combine a few of the questions and hopefully add some structure. So there were some questions around websites. So this is particularly useful for someone who has never used Shiny before. People were asking if there are any websites that you may recommend for someone who's trying to learn Shiny. So Aidan, followed by Edward, your thoughts?
Yeah, I think the RStudio's Shiny website has a great introductory set of kind of tutorials which you can go through, and just to get started and get a kind of a simple Shiny app put together. I think that's definitely the place to go and begin. Obviously, there's more advanced ones. There's books written as well. So as you kind of progress, there's other resources as well. But I think to begin, RStudio have a set of Shiny tutorials which are quite good.
Yeah, I'd echo that point. The only other thing which I found particularly useful was to basically the Shiny gallery is kind of full of these amazing apps, and I often I would find an app that did something that I wanted to do, go through to the GitHub and find the chunk of code, and then adapt that to do what it was to do it in my own app. So kind of targeted searching of that gallery I found to be really helpful, and then basically kind of repurposing their functions into my own dashboard.
Great. Thank you. There were some general questions about accessibility. Can dashboards be accessed on mobile phones or tablets? Again, is there something that you guys have experienced or have any idea on?
So maybe I could go first. Just that there are some. It's not. The app works best on I develop works best on a desktop or a laptop. There are certain just inbuilt aspects of Shiny that are reactive to the size of the screen that you're looking at, but then occasionally a graph will render and it will just be squished and you can't see it properly. Some pages work really nicely with no input. There are options to tweak it, to tune it to be more reactive. I haven't got to that advanced level yet, but the nice thing is that a lot of the basic things are reacting to the screen just by default. So most aspects do look fine, whatever you're looking at, whatever screen you're looking at it on.
Yeah, I'd agree with that. So it kind of depends with the app. If there's click and drag, it may not work as well on a phone, but it will still load up in the right size. The bus app that I have works fine on a mobile because it's simply just a table. So it'll load up in the right size to your screen. There is one package, RShiny Mobile, which I bookmarked a tweet from ages ago, meaning to get around and looking at it, but I haven't. So people are working on ways to kind of improve the mobile, because it will just be the main web page loaded up in the smaller size. So while it will load, it may not be as useful depending on what content you're showing.
Okay, great. There were some questions around using other software and linking it with R. So I think there were mentions of Stata and then SPSS or maybe SQL, like you mentioned, Aidan. So is there a way, or can you, or have you easily linked other software with R and then with RShiny and deployed it? Is this Aidan or Edward? Do you guys have any experience of that? Yeah,
I've done it with Python. So I've apps that work in work that we run some Python code in the background and Shiny sits on top of it. So Shiny does some of the processing, then some of the heavier lifting gets run in Python. In terms of SPSS, I'm not sure. As I mentioned, I have an app as well, the SQL, so you can run SQL. There's the dbplyr package is quite useful for that. So you're not really, even if you don't know SQL code, you can actually use OR to access the database. So yeah, there are for certain languages. I know Java as well, you can run in C++. I'm not sure about some of the other statistical packages. I don't have experience myself.
I'll leave that to Aidan. I don't have too much experience of that. It's because I learned in R, therefore I never kind of had that bridge to cross. But I mean, as a general rule, I've found that where there's a will, there's a way with these things. And any issue I've had, someone else had 3 years ago if I Google it. So if there's at some point, if you're going to use Shiny, you'll have to bridge into R, but there may be ways to make that bridge seamless and easy. And someone else has probably already thought about it. So Google is your friend for that one.
I'd massively echo that. Google Stack Overflow. If you have a problem, someone has most likely had it before you. So it's just learning how to correctly Google it and you'll find the solution, usually.
Great. Aidan, you mentioned the RShiny contest. For our career young statisticians who've joined this session, do do you have any advice or recommendations for someone who's aspiring to take part?
Yeah, I think just look out for the deadline and set yourself that deadline. I found it quite useful because I played around with that app for a long time and never actually went anywhere with it. And then when I set myself that deadline, it was something to work towards. So it kind of helped me along a bit motivation wise. I think it's good just to pick something that is useful for yourself. Like I use that because I couldn't look at 2 bus stops at once. And so it was just quite a nice thing that I could then go and use. They're looking for kind of nice, innovative. It doesn't have to be really fancy. Like there's different categories. So there are some very complex apps which win, but sometimes it's just showing a nice, neat solution that they're looking for. So I go with something interesting that would be useful for yourself. I think that you find interesting is it's usually how I help myself be more motivated.
Great, thank you. Towards the start of the presentation, there was a question around including interactive graphs in papers and journal articles. Edward, is there something you've experienced, or I know obviously with things progressing as we are all moving towards interactive visuals, there's often that discussion about how you improve that and incorporate that into science. So what are your thoughts regarding that?
I mean, I think it's a great question, and it's definitely motivated a lot of my interest in this tool, because to me, if you take the example of like a sensitivity analysis where you've got this is the way we did it and these are the other ways we could have done it. If you are submitting an online supplementary PDF, you're limited in what you can fit into that. Whereas Shiny is perfect because it's basically giving the user control, saying you can slide anywhere and combine these in interesting ways and you can explore this. And that's to me where we should be aspiring to be at when we present data and present the kind of uncertainty around that data. So to me, like in an ideal world with infinite time, every paper that I wrote would have an accompanying online appendix as a sensitivity analysis. I've started to do it. So there's the odd paper where I have in the appendix is like, you can go onto the this Markdown file online or a Shiny app and to explore this further. And increasingly I'm seeing that happen elsewhere, where there's just an accompanying Shiny app to a paper. And sometimes a Shiny app is a paper in and of itself as well. But so it's not the norm, but it's certainly a possibility where just in that list of supplementary materials, you would just say, including interactive online appendix. And I'd love to see it more. I'm going to try and do it more, and I hope others will as well.
Great, thank you. Okay, this is a personal question for me, especially so young statisticians who are trying to make their first Shiny app, and this is something that people may not discuss, but personally, you guys, is there something that you have struggled with when you were starting your Shiny journey, per se? Is there something that you got stuck with, and a piece of advice that you could give to career young statisticians?
I'll go first this time if you like. I think with Shiny, there's a different way of thinking to normally when you're coding the OR because of the reactive elements. So the likes the sliders and clicking, which you may not have kind of been used to or may not be used to. So there's a little bit of a learning curve there with kind of thinking about how when you change a slider, what parts of your code actually update. So that's just something that I think you just have to start building and you get used to it. I don't know what's a good tip on that. I think it's just start small. Don't try kind of go too big with your first app. Try to get something relatively simple, just 1 or 2 sliders, and see how that goes and kind of build up from there. Once you get used to it, you kind of it becomes a bit more natural. But it's definitely something that I think when I first coming from just because I originally came from just OR coding, that reactive style of how things update, I wasn't used to it all. It kind of just took me a while to get my head around it.
Okay. Edward?
Yeah, it's definitely echo Aidan's point that it's hard to sort of take a complete bit of analysis and say, I'm now going to make the app version of that. So starting small and building up was definitely the experience that I found helped. As I mentioned in the talk, I've kind of had in the back of my mind, I've got to learn how to do this for a long time. But I think learning it in the abstract of just kind of seeing these apps that were available only took me so far, and actually just kind of blocking off. I got basically a bit obsessed with this app for about a week and didn't think about anything else, and just sort of gave it all of my time and attention for a short window of time, and just learned so much. And it started from kind of a blank page and saying, just want to build a graph or a map that does A. And then when it could do A, I was like, I want it to do A and B. And then when it could do those, I built it up. And so, persevering and giving it, starting with something that you want to do, giving it all of your, obsessing over a couple of days and building it up slowly and sticking with it, because it is incredibly satisfying. And there will be a kind of a bit where you want to just change the way something looks slightly, and you think, well, that should take 5 minutes, and it takes 3 hours. And but when you finally get it, you'll think, oh, well, that looks exactly like I wanted it to look. So it is kind of satisfying. Yeah. You have to kind of persevere through the trauma of trying to move a box slightly to the left, and you'll get there and be satisfied. So I found it to be really worth it in the end. And now I just can't stop making apps, basically.
Great, thank you. Thank you both. That very honest answer. I really appreciate that. There are a few more questions. So, well, this is quite controversial. There are a few questions towards the end about Power BI and which one is better. Do you guys have any experience with Power BI or any personal favorites? Aidan?
I have no experience in Power BI, so I can't answer that.
That's fine. Edward?
Me.
Okay, so,
Sorry.
well, we'll leave that for a different session then, and say we're focusing on R. There was another question about confidential data and what potential hurdles exist for hosting confidential data on the Shiny apps server. Aidan, you?
Yeah, this is one of the harder parts, especially if you're using the open source version. So if you're using the free version, it's quite hard to make sure that you have the app fully secure. If you're having even logins can be, there is ways to do it, but there's not very many elegant solutions. And especially if you're putting it together yourself and you're not a kind of security expert, I don't think it's going to go so well. There are the Shiny apps IO. Once you go up the plans, you can add authentication in. So again, you're paying for it. There's also if you want to use Amazon Web Services, there's our Studio Connect. But like you're talking, I think it's 15,000 for that server at the most basic. So to get proper authentication, it's going to cost. It can be done, but you kind of have to upgrade to a more professional kind of version of Shiny. Once you get to that stage, it becomes a lot easier. But to do it in the open source version is quite tricky unless you have a lot of experience yourself in maintaining users and passwords and hashing passwords, that kind of thing, which is a bit more kind of advanced.
Okay. Edward?
Thoughts or? That sort of echoes my understanding of it in terms of if you're going to use the free version, you are kind of generally trying to not do so with sensitive data. That being said, the general move for a lot of scientific data is to get things into the public domain. So in general, there is this move towards the sorts of mechanics that of data sharing that are going to remove those obstacles. So hopefully it's part of a trend where, obviously highly sensitive, highly confidential data, don't be putting on a kind of free to use first Shiny app, but anonymized data that is going to be sort of shared as part of an appendix anyway, with the new kind of rules in place with more and more journals, is hopefully going to fit well with a Shiny app.
Great. Thank you. I think that is all the questions we have. I can't see anything else. So thank you again to both our speakers for such an interesting talk And hopefully we will have a lot of statisticians going away and making a lot of Shiny apps, and we'll get in touch with you if they have any questions. Thank you to everybody in the audience for joining this session, and feel free to get in touch with the speakers if there are any questions that I may have missed. And I'm sure they'll be happy to answer all your questions. So thank you, everyone.
Thanks.
Thank you.